Hello everyone and welcome back to Newton's Academy past paper review for grade 12. Today we will be doing a past paper question on the physics topic electrodynamics. And that will be question 10 that we see here in front of us. So let us get right into it. Question 10 gives us a simplified diagram of an electric motor as shown below. Right, so we have our motor, we have the magnet, we have the coil, and we have the split ring, etc. 10.1.1 asks us to name the components labeled A, B, and C. So A will obviously be our magnetic coil or our wire coil. Component B will be our carbon brush, and component C will be our split ring commutator. So let us write that down quickly. 10.1.1. So A was our coil, B was our carbon brush, and C was our split ring commutator. Okay, and those are the parts they asked us to label. Okay, 10.1.2 asks, write down the function of the component labeled B. So B is a carbon brush. The carbon brush is made out of graphite, and they want a function of this carbon brush. So the carbon brush has the primary function of taking current in and out of the coil. So the first function is to take current into and out of the coil. And the second function, or the secondary function, is simply to keep contact or to maintain contact with the split ring commutator so that the circuit is complete and that the current flows. So with the split ring commutator. Okay. Question 10.1.3, is this an AC motor or a DC motor? So this will be a DC motor. Why? Because we see a split ring commutator. So 10.1.3 is a DC motor because AC motors have slip rings. DC motors have a split ring commutator. Okay, 10.1.4, give a reason why component A experiences a magnetic force when a current passes through it. Component A is a coil, and the force it experiences is described by the motor effect. So the reason is due to the motor effect. Okay, and what does that state? That simply says that there's an interaction between the external magnetic field, so basically between the magnetic field supplied by the magnet, between the external magnetic field and the magnetic field created by the current passing through the wire. Okay, so that describes why a force occurs. Okay. Interaction between exterior magnetic field and magnetic field due to the current in the wire. Okay, 10.2. A coil is rotated in a magnetic field. The varying induced EMF obtained is represented in a graph below. So obviously this is in a generator, so this question does not have anything to do with this motor question. Okay. Calculate the induced RMS potential difference. So the induced root mean square voltage. We can see this is a graph of voltage against time. It's an AC generator because the voltage becomes negative, which means the current in the circuit flows in the opposite direction. They want the root mean square voltage, and there's a formula for this. So the formula for our root mean square voltage, let us just make some space here. Okay, so our root mean square voltage, this is 10.1.2 or 10.2.1 rather, 10.2.1. Our root mean square voltage has the formula V max divided by root 2. And the V max we can see from this graph is the maximum potential difference is 1 volt. So we simply say 1 all over the root of 2, and that will equal to 0.71 volts. Okay. 10.2.2, the coil is now rotated at twice the original speed. Write down the period of the new wave. So if it's rotated at twice the original speed, that means the frequency doubles and the period halves. So meaning the original period here we can see was 0.8 seconds, right? The time it takes to complete one wavelength, 0.8 seconds, but we're doubling the original speed. That means our new period will be half, meaning we will get a full cycle in half the time, which is 0.04 seconds. So 10.2.2, the period is 0.04 seconds, and the reason for that is we double the velocity or the speed, and that means therefore our frequency is doubled, and therefore the period is halved. Okay. 10.2.3. Calculate the average power generated if the generator produces a maximum current of 2 amps. So that's the maximum current, not the root mean square, so we might have to convert it. So let us write our formula for power. 10.2.3, power equals V RMS multiplied by I RMS. And we have formulas for those, so V max all over root 2 multiplied by I max all over root 2, which basically equals to 1 all over root 2 multiplied by 2 amps all over root 2, and that will give us the final answer to be 1 watt. And that will be the power, or the average power generated if the generator produces a current of 2 amps, a maximum current of 2 amps. Okay, and that brings us to the end of this question on electrodynamics. Thank you for watching.